After this point, it'll be posted. We might have different chiefs. Okay. All right, so we're going to start with the table. We're going to fill this in together. We're going to talk about some relationships. In order to understand trig, because this is what we're going to get into, you have to know the parts of the triangle in relationship to an angle, okay? Because we're not going to have special rights when we do trig. We're going to look at like angles like 43 or 32, okay? Okay, so this symbol that I have up here, this is the symbol for theta. Sometimes it looks like a zero with the line through it. You need to kind of get familiar with that because they kind of use that symbol a lot for an angle, okay? So the one part of a triangle that never changes is the hypotenuse because it's always opposite the right angle. So what we have to do is start off by labeling our hypotenuse, and I'm going to abbreviate height for hypotenuse. So B is the hypotenuse because it's always opposite the right angle. Now the other two remaining sides that you label is in relationship to the angle. That's why I always start off with circling the angle. They will give you an angle measurement, so you circle that to see what you're starting from. This arrow is pointing across to the other side. So we label this side opposite. Okay? C is opposite our theta, our angle, our reference angle. Then this arrow is pointing like to the left here, saying right next to you. That would be adjacent. So in order to even start trig, you have to know that. You have to be able to do that. Because if you do this incorrectly, you're going to use the wrong ratio. You're going to get wrong calculations, okay? So I'm going to see if you can label correctly. On this next one, B, this beta right here, that's our reference angle. I want you to fill in the blanks in relationship to that. D would be the opposite. F would be the adjacent.
And E is height.
And E is our height, our hypotenuse. Okay? Are we okay on that? Okay, that's the basic foundation. Be able to do what we're going to do next is based on this. All right, so our trig ratios. All right, our trig ratios, sine, cosine, tangent, SOHCAHTOA. I'm going to talk about chief SOHCAHTOA to help you, remember your trig ratios and the relationships. That is why, yes, I'm channeling chief SOHCAHTOA right now, okay? All right, so, and this will help you set up your problems right, or just remember the relationship. So, many moons ago, okay? All right, there was this young brave warrior. He wanted to be the youngest chief of his tribe, okay? He was the strongest, fastest, most kills, all that great stuff. All right, so, but in order to be a chief, you have to also have great wisdom and intellect, okay? So he went to the medicine woman, asked for some advice, like, what do I need to do to become the youngest chief? She knew that they were about to hit a hard winter, and so they needed to figure out a way to replenish their crops. Basically, he had to come up with a better irrigation system, which required on right triangles, okay? And he did, okay? But he had a crazy event happen. She gave him the problem. He goes out into the fields, tries to figure out the problem. He's not getting the problem. And in his frustration, he kind of like kicked the ground, and he stumped his toe. And they're breaking his toe. He's out of commission. He's not the young, brave warrior anymore. He doesn't get to go on the hunts anymore. So the blessing in that was he had time on his hand. And because he had time on his hand, he was able to figure out the problem, okay? But he wanted to get back into the, to the swing of things. He needed to get back on the horse. So he goes back to the medicine woman. He's like, what can I do about my foot? I need to do something to fix this. She goes, go to the creek, put your foot in the creek. It has healing powers. So he sits out there, puts his foot in the creek, and he's thinking about the problems, and he came to a solution. Where he ended up using trig, the relationship with the angle and the sides, to come up with a better system. Now, in the tribe, when you get named chief, you're named by a significant event in your life. So when the medicine woman had to name him, she named him Chief SOHCAHTOA. Because he soaked his toe. But SOHCAHTOA, so S stands for sign, okay? S is for sign. O and H. O is the relationship. To get the relationship with sign, you do the opposite over the hypotenuse.
Oh.
So sine is always the ratio of the opposite side over the hypotenuse. So that's the SO for Chief Sokoto. Okay. C is for cosine, and the relationship for cosine is now adjacent over hypotenuse. Yep.
Over that height.
Yep, over the height. Okay. And then tangent is opposite over adjacent. Exactly. Okay.
Hey, that's a nice story.
There we go. All right, so what we're going to make sure you can do right now is write the ratio, understand how to use your calculator in relationship to the ratio. So if I'm looking back to our example, theta, if I do sine of theta, that's going to be C over B, right? That ratio. You write it as a fraction, okay? You write your ratio as a fraction. All right, what would the sine of beta be? Opposite. Yeah, D over E. There we go. And then cosine would be A over B. So here's theta. Cosine is adjacent. That's the A. Over hypotenuse, which is the B. So it's A over B. Which names? That's just the symbol that was on there. So the ratios are on your formula chart. Yeah, the next one would be F, because F is the adjacent over E, which is the hypotenuse. All right, what would be the tangent of theta?
C over A.
Yeah, C over A. F is the adjacent. That's the side. And then tangent of beta? D over F. Okay. Now, the first part, what we're going to do and ask of you is to come up with the ratios or use your ratio to pick which angle is being used. Okay? Now, I need to talk about how we do this in the calculator real quick. So, go to your calculator. I need to show you how to get to Trig. So, you do need to physically do this. All right, we're going to go to a new document. I don't want to save mine. We're going to add a calculator, add a calculation. Okay, now, let's say we do sine of 30. To get to my trig ratios, right below the control, the blue button, there's a trig button. Hit that trig button. Mine's going to probably go crazy. You're just not going to do that.
Add calculator.
Add calculator and then hit trig. Yeah, put it on my desk. Because it's just doing that. Don't worry about it. It shouldn't be blinking. I'll fix it. Oh, no. All right, there it is, trig. All right, so you will be responsible for the first three, sine, cosine, and tangent, and the inverse of those, okay? That's doing the opposite of what we have to find. All right, we will get in cosecant, secant, and cotangent in a little bit, but do sine, so hit the sine button, and then 30. 30 degrees. And hit enter. Okay, we'll just borrow it somewhere. All right. Okay, good. I'm glad you got a different answer. That can happen. Let me explain to you what happened on my calculator. Okay, yeah. Okay. Trig, sine. Tochi, are you good? Sine and 30. And hit enter. I got a negative answer. You probably got a different. You get a negative answer. Okay. Okay. That's fine. That's fine. That's fine. That's fine. Okay. Okay. I'm gonna fix it. Why you have two different answers? Because you have to tell the calculator how to calculate your function. Okay. Right now, if I see a negative answer, that to me is a clue that this is not doing 30 degrees. It's not doing a sine of a degree. It'd probably be doing a sine of something else. So if you ever come across an answer that looks wrong because it's negative, I'll show you how to fix it. Hit the home button.
Where's home?
That's the very top. Hit your, yeah, the home, yeah. Hit the 5 settings and then 2 document settings, and it tells you the settings of your calculator. Okay, I'll do it again. Home 5.2. Home 5.2. Okay, so look at my settings. Anyone have a different setting than mine? Yeah. My setting is in radians. You should be in degrees. I need mine to be in degrees because we want the sine of 30 degrees, okay? So my calculator's wrong. I'm not wrong. My calculator's wrong. All right, so I will remind you to make sure that it's in radians, huh? I mean degrees. Radians, what? Yeah, you are using, yeah, it's a relationship of a radius to a circle. Yeah, we'll get to that. Okay. All right, so now if I go back to where I was, now I got 0.5, which is right. Okay, but yeah, make default. I would change to make default.
How much is the full version? Because I have the trial for this app.
The app? I don't know. I have to check. I know sometimes it's on sale.
Oh, really?
Yeah. Okay.
I have like 40 days.
All right, so sine of 30. What's the complement of 30? Complement of 30. Yeah, 60. All right, so do the cosine. Now do the cosine of 60. And what happens? Oops, I did cosine 30. Cosine of 60. Yeah, hit it again. Yes, did you get the same answer? Okay, so that's the first little relationship with trig. Okay? I did 30. I should let 2 grades. I know, because you did cosine of 30. Do cosine of 60. The complement of 30 is 60. The complement of 60 is 30. So do the cosine of 60.
Oh, because it's degrees.
Yeah, because it's degrees.
It's out of 90 degrees.
Out of the 90, yeah.
Nice.
Yeah.
But where does it get the 0.5 from?
Oh, I'm going to show you that. Okay, so
Is that just telling you that it's half of the value?
it's the ratio. All right, so the sine, and if I abbreviate sine, that's S-I-N, sin, okay. The sine of an angle and the cosine, cos, of its complement are equal. Okay, so basically if I do sine of 30, that was 0.5, and then when I do cosine of 60, that was also 0.5. Now, I didn't double. Well, yeah, but they're complements of each other because 30 plus 60 equals 90. All right, now, the reason why this is, let me just show y'all real quick. So, we've done 30, 60 triangles, right?
Yes.
Okay, so our formula for 30, 60, and watch this and pay attention. I'm going to fix it. Short leg is x. Hypotenuse is 2x, right? And long leg is x squared root of 3. Yes, okay, so when I'm thinking about the relationship between sine of 30, that means I'm looking at the 30 degrees. I put the angles in the wrong spot. That's my fault. Sorry. This is 30. 30, sorry. All right, give me a side. Pick a side that you want for your short leg. Any side, because this x could be any number. A number. Give me a number. 2. Okay. All right, so let's say our short side is 2. Okay? That means that our hypotenuse would have to be 4. Okay, so if I'm doing the sine of 30, that is the opposite, because that's opposite, over hypotenuse, right? So what is 2 over 4? Equal 1/2, and 1/2 is 0.5. Okay? Okay. All right. Okay. What? Because I did sine of 30. Yeah. I said.
Apparently, 7 times 13 is OB.
So y'all just told me that this side is now going to be 2. And that means that this would have to be 4. So this is my angle. If I look, that's opposite. This is hypotenuse. Sine is always the ratio of opposite over hypotenuse.
Oh.
So that's 2 over 4,
So it's the
which is always 1/2. Okay.
So the long
It depends on what angle you pick, yes. The long one? No, the ratio, the sine, the ratio of 30 is 1/2.
So it's not actually.
Oh, but I would say 45. 45. Is that what?
Okay, so yeah, it'd be 1 and what?
One.
No, because that's leg and leg.
Right.
Yeah, if it was 45, think about that. This would be 1, 1. This would be square root of 2. So it would be 1 over square root of 2. Yeah. Okay, so we're going to go over the remaining properties in just a second, okay? But I need you to understand the two, make sure you know how to do the sine of a trig function. And then gives me the ratio. That's 1/2, the decimal. Listen up. So if I want to find the angle, notice that this number in the parentheses is the degrees, but you can do the inverse of a trig function to get the angle, the measure of the degree, all right? So watch this. Hit the trig button again. Instead of, oh, mine is blinking. Instead of doing sine, do sine inverse. That's the one below the sine. See that -1? That's the inverse symbol, okay? All right, so I'm going to go back. Sine inverse, you got that? Sine -1. All right, put 0.5 in there. And it should equal 30 degrees, exactly. Okay? So inverse gives you the degrees, all right? No, you would have to put cosine inverse of 0.5, and that would be 60. Yep. Okay? All right, so what I need you to do, we don't need that part. Go to your foldable. Go to your foldable now. Go to your foldable. I have a feeling this was not on. Oh, yeah, it is on. Yeah, go ahead. Foldable. All right, the first tab gives you your ratios. Just a reminder, opposite over hypotenuse, okay? Adjacent over hypotenuse, and tangents opposite over adjacent. Now, if you want to, another way to remember it or to write T SOHCAHTOA, I do a capital S to show the trig name, that's the sign, and then I do O over H. Okay? And then a capital C, that's cosine.
It's like a man.
That's A over H. Capital T, TOA, O over A. So that helps me make sure I set up the ratio correct for each trig function. Okay? So what we're going to do is we're going to write the ratio, and we're going to come up with the angle. Okay? So on this first tab, A, says sine of U. U is the angle that is our reference. So I'm going to circle the U. All right? Then label everything in relationship to that angle. So the 17 is what?
Size.
It's the hypotenuse. So I'm going to hype it up. There's the hypotenuse. All right.
Hype it up.
Then the 15 in relationship to the angle that we circled. Yep, that is opposite. OPP. OPP. Okay. Yeah, you know me. All right, then. I don't know that song. All right, so A is what? Adjacent. Okay, so I'm going to label the parts. And then I'm just going to give the ratio for the trig. So if I'm doing sine of U, that is always opposite over hypotenuse. So that ratio would be 15 over 17. And that's all I need. Okay, 15 over 17.
You don't need to until you
Okay, now to do cosine of the angle U, cosine is adjacent over hypotenuse. Cosine would be adjacent over hypotenuse.
Okay.
Yeah. So that would be 8 over 17. There we go. Now, to do the tangent of U, tangent was over A. So that would be, yeah, 15 over 8. And that's just writing the ratio. Yep, that's it. Okay?
That's just writing the ratio.
That's writing the ratio. Now, if I wanted to find the angle, okay, we're going to work smart, not overwork, okay? So, to find the angle, the degrees for the sine of u, like the actual degree measure, you would have to do sine inverse of that ratio.
Yeah, that makes sense.
What?
I think you should slack
The angle,
the angle of
the degrees. This is for the degree of the angle. Angle u. There it is. Okay, so that's when I have to go into the calculator.
It's 60.9.
9, yeah, that's right. So when I go on my calculator, I'm now hitting
61.9. I already said it.
and we're doing, what was it, 15 divided by 17? All right, yes. Sine inverse. Stop. Inverse, right? Okay, did y'all understand? We got the angle. This is the degrees. Now, when we do the degrees, we have to round to the nearest whole number, whole degree. So this would actually be what? 62 degrees. All right, so that means that now that I know that this angle here is 62 degrees, then I could figure out angle P because they're complements of each other.
Yeah, so you just
So-
sign.
I don't need to do sine. What's the complement of 62?
Yeah, that one.
28. Just subtract it from 90, and that gives you the other angle. I don't need to do trig for the other angle. I need it for one, but I can use math to get the other. Mental math. Okay? All right, now, for our next tab, see if you can come up with the ratio, but notice that we are going to have to simplify because we do have some radical sides. So, they said sine of j. J is my reference angle. Sine is what? Opposite over hypotenuse, right? Who is opposite of j? 3. What is the hypotenuse? 9. So we would write 3 over 9, and we would reduce that. That would end up being what? 1/3. All right, we got the sine of j. To do the cosine of L, this is this angle over here. L is now our reference angle. Cosine is what ratio? Adjacent A over hypotenuse. Which side is adjacent to L? 3. Okay, 3, and then over 9. Yep, 1/3. Didn't we just do that just a while ago? Yeah. Remember, they're going to be equal because they're complements to each other. They're equal because they're complements to each
They're
other.
always going to equal each other, right?
The complements are, yes. All right, now, tangent of J. Tangent would be opposite over adjacent. 3 over 6 root 2. Now, can I leave it like that? No, because we can't have a radical at the bottom. So we need to rational. So we have to simplify it, rationalize that.
12, but then you can simplify.
I'm not 12.
What is that?
No,
Yeah. Yeah. Are we okay on that? All right, sine of L. Sine of L.
L is
L, opposite of L is, okay, so we would write 6 root 2 over what? 9, the hypotenuse. Opposite over hypotenuse.
Which is
9 is always the hypotenuse. Opposite would be there. Which would be, yeah, root 2 over 3. This gets simplified to root 2 over 3. Yep. Yep. Because 6 can be divided. You can reduce 6 to 9. Yeah. All right, now, this is how you really will be tested. So you might want to start this next example.
wait. You want under it?
Yeah.
Start
Yeah.
next example.
All right. Now, what we just did, that's the first step to writing your equation. So you will need to be able to write the ratio, like write the number, simplify it. But here's how I would check to see if you really know trig. And this is very similar to SAT. So it says, use the given to determine which angle of the triangle is angle A. So the angle that we're trying to determine, is it 1 or is it 2? Okay?
Well, how do you know?
Well, because it says the sine of A is 4/5. But what's the sine ratio always? Opposite
Opposite over
hypotenuse. Okay, so if it's 4/5, think about this. The 4 has to be the opposite side, right? And the 5 has to be hypotenuse. Okay, so look at our numbers here. We have 6, 8, and 10.
Oh, it's 8 over 10.
Right. So this would be the same as 8/10. Okay, so, right, 8/10 would give me 4. Yes, because you go opposite of 8, and that means that this would be angle 1. You're absolutely right. Angle 1 is for the first one. Okay. All right, now, we have the sine of A equals 0.6. Which ratio would give me 0.6? What is 0.6?
That's 6 and 10.
6 and 10, right?
So, yeah,
And I'm sorry, it's cosine. Cosine is the adjacent over hypotenuse, right?
Yes.
All right, so that means the adjacent side would have to be the number 6, right? And the hypotenuse would have to be 10, which it is.
So therefore,
Who's adjacent to 6?
1.
Angle 1.
Yeah.
So angle
Okay. How what?
So really, you didn't have to do the second one, right? Because you already knew the answer with.
Yeah.
5.
Yeah.
But that's just 2
Yeah.
ways of doing it.
Okay. Cosine of A equals 0.6. This is our ratio. I'm just going to change that to cosine of A equals 6/10. So basically what they're saying is my angle that I'm using gives me the ratio of 6/10. Cosine is always adjacent over hypotenuse. So that tells me the adjacent side is the 6 because that matches up, and the hypotenuse is the 10 because that matches up. Well, if I look up here, there's my hypotenuse, there's the 10. 6 is the adjacent side, there's the 6. What angle is adjacent to 6? That would be 1. And that's how you get to your answer. Okay? You're working kind of backwards. Yes, there's a whole purpose of the hat. Okay? No. I've been wanting to add feathers to it for the longest. I just haven't done it. Now's my time. Okay, so finding the side using trig. This is what we're going to do next. Put that up, please.
Sorry.
All right. Next tab, real quick. Yeah. Finding the side using trig. All right, the way it starts off, always start off circling your reference angle. Circle the angle. Yeah, and then we label in relationship to that angle. So x is opposite, right? The 13 would be adjacent. We don't have the hypotenuse labeled. There's no measurement there, so I don't need to label that. Don't label extra stuff. Just label what's given, okay? All right, so what trig, then you ask yourself, what trig function deals with opposite and adjacent? Yeah, that's TOA, right? So that's tangent. So you write the tangent of 32, the degrees, equals x over 13. Yep. So we write the degrees and we write the ratio. Now, the way we solve this is we basically, the tangent of 13 is like saying over 1. We have a proportion here. We would cross multiply. So, x equals 13 times the tangent of 32. Put your tangent together. Okay. What was that? Okay. Yes, all right. I know. Okay, so the reason why I just want to show you this. The reason why you write it like this, because you're not multiplying the 13 times the 32. Do not do that. 32 is degrees. This is a side length. This is like centimeters. No mixture units. So you would have to go 13 times the tangent of 32 and hit enter. Okay. All right. So I will be telling you on these type of problems, I will say round to the nearest tenth or to the nearest hundred. Rule of thumb is usually nearest tenth, so this would just be 8.1. 8.1. Are we okay on that? All right, now, let me show you the next one real quick. What do we do first? Circle your angle. All right, 11 in relation to the angle is what? Adjacent. X is what? Hypotenuse. All right, so the height. So what trig function deals with the A and the H? Or adjacent and a hypotenuse? Cosine. Okay, cosine does what adjacent and hypotenuse. So we write cosine of 37 equals adjacent, which is 11, over X. Now do this with me because you need to notice there's a difference in this ratio. Okay, we put this over 1, and we're going to cross multiply. 11 equals X times cosine 37. That's right. Now we're solving for who? The X. So to get this X by itself, we're going to divide by cosine of 37. Because that would get the X by itself. So 11 divided by the cosine of 37 equals X. So you type in 11 first, then you divide, yes, cosine. Sorry, divided by cosine 37. So this would be 13.8, right? 13.8. Okay, now, let me just talk about something real quick. Now, I need you to see the difference in these ratios real quick. In this one that we had, this was the first one. Notice where X is. On top. Okay. And then on this one, notice where X is. Bottom. Okay, so this is a pattern. This is a relationship when you're doing your trig ratios and writing the equation. If X is on top, you always multiply to get to your answer. You multiply the number times the tangent. Does that make sense? Okay? Because basically 1 times X is just X. We multiply to get the answer. Notice when X was on bottom, what did we end up having to do? We had to divide. So all you have to do, I'm going to go back to what we started with. We had cosine, oh, I want to do it in black. Cosine 37 equals X, 11 over X. 11 over X. All right, so whenever X is on bottom, this is what I say to help you shortcut. Switch these two. If X is on the bottom, switch them. Okay? Because then that means the X will come over here, 11 will be on top, and then your cosine, your trig ratio or function, will be at the bottom. And now you got your answer. Yeah, you can do the long way. But I'm just telling you, that's always going to happen. Okay? All right, so the homework will be finishing the foldable because I'm going to do the one more tab, which is the inverse, finding the angle, okay? And then you need to be working. Remember the front page, this page, the first page, okay? First page, front and back, yes. Hold on. It'll be 2 separate videos. I'm going to work on them today after school.